It started as a technological race with the Soviet Union, but has evolved into a search for knowledge about the planets, the solar system, the universe. It has shown us Earth as never before seen, shown us too how fragile it is. The U.S. space program, beginning its third decade. Here are a few highlights of those first 20 years. One week after the forming of NASA, October 1st, 1958, Project Mercury, America's first manned spaceflight, was given the go-ahead. 3 years later, on May 5th, 1961, Alan B. Shepard took a 115-mile suborbital ride in the Mercury spacecraft. Grissom, Glenn, Carpenter, Schirra, and Cooper also earned their astronaut wings in Mercury. Then, following in succession, 10 Gemini flights with 2 astronauts in each spacecraft. We learned how to rendezvous and dock with another object in space, a maneuver critical to future moon landings. Spacewalks added a new entry for all future dictionaries. Problems overcome in Gemini resulted in solutions for the 3-man Apollo program. Except for the tragic on-pad fire resulting in the deaths of 3 astronauts, the Apollo program went well. 12 American astronauts walked on the surface of the moon, returning 850 pounds of lunar soil and rocks for analysis. In 1973-74, Skylab, a manned orbital laboratory, was occupied by 3 different crews for 28, 59, and 84 days, respectively. In 1975, American and Russian astronauts completed an international link-up in space during the Apollo-Soyuz test project. Meanwhile, the level of activity in space science research continued. Small sounding rockets have probed the atmosphere surrounding Earth, and larger spacecraft were hurled outward to the planets, Mercury, Venus, Jupiter, including 2 soft-landing Viking spacecraft on Mars, probing, photographing, returning a stream of information about these various distant planets and the space in between. Working with numerous other agencies, NASA has been able to bring the benefits of space to everyday life through its applications program. These include television via satellite from around the world, photographs of the weather used by meteorologists, and Landsat and Seasat satellites that observe Earth and the seas, helping us manage our natural resources. Before 1958, NASA's sole concern was aeronautics. Research on nearly everything that flies remains as the single constant thread linking past with future. Craft that fly fast and slow, planes that fly straight up and down, wind tunnels to full scale. Aeronautics has and will continue to play a major role in NASA's future. And this is also part of NASA's future, the reusable space shuttle, a craft that can maneuver in space and then return to Earth like an airplane, a space truck for hauling people and equipment to and from space. The 20th year, a look back and a look ahead. There will always be new frontiers and new discoveries to be made in both aeronautics and space. We are limited only by our willingness and resources to continue the search.
the fantastic metamorphosis taking place in the growing, processing, and packaging of foods, keyed to concepts such as fresh frozen, cured, dehydrated, freeze-dried, reconstituted, and others too numerous to mention, is not only changing the physical aspect of our daily bill of fare, but is making our meals more interesting, appetizing, nutritious, healthful, and better tasting as well. Even I've been repackaged, and I like it. The advent of the space age, the Gemini, and now the Apollo program pose new challenges. Innovations in packaging and processing were necessary to create for the astronauts a bill of fare that was as exciting, nutritious, and delicious as a breakfast at Brennan's, a luncheon at 21, dinner at Perino's, or an after-theater snack at Sardi's. The inauguration of this special food program resulted not only in innovative and tasty space goodies, but its overall impact is well on its way to changing the eating habits of millions and millions of Earth people, like you and me. Now, although the food program's emphasis was on meals in space, mealtime as we know it took on different dimensions. Due primarily to the fact that an orbiting spaceship moves from night to day in 90-minute cycles, and the workload of an astronaut, like that of a housewife, being almost a continuous one, space eaters are all loners. Other considerations involved the volume and weight of a quantity of foods requiring no refrigeration or cooking, convenience foods that would provide each astronaut with a daily intake of approximately 2,800 calories for a journey of up to 16 days in space. Experience gained during the Mercury and Gemini missions in the preparation, handling, and consumption of space foods provided valuable background in the development of our menu for an astronaut. Each astronaut is furnished 1.4 pounds of foods per day. Its nutritional content is balanced to provide 20% protein, 62% carbohydrates, and 18% fats. Its caloric distribution is 17% from the protein, 51% from the carbohydrates, and 32% from the fats. All food and beverage packets for one meal are placed in aluminum overwrap packages, and each overwrap has a color-coded tab to designate the meals selected by each astronaut. Both the food and hygiene components are stored aboard the Apollo spacecraft in fireproof containers. Like you and me, astronauts savor foods that retain their original color, taste, and texture. A wide variety of nutritious foods, over 50 different items, is selected and prepared and processed. Each is selected to please taste and satisfy appetites. And since their peak physical condition and mental attitudes requires balanced nutrition, the foods are personally chosen within certain limitations by the astronauts themselves. So, how did we create our menu for an astronaut? Easy. We asked them what they like to eat, and they told us. What we're interested in finding out is what you like to eat for breakfast, lunch, and dinner.
Well, for breakfast, I like cornflakes with strawberries and cream. Lots of sugar, too. Add some crisp bacon, a couple of eggs sunny side up, some raisin toast, blackberry jam, butter, and, well, of course, a fresh glass of orange juice. For lunch, there I like a little more variety. Perhaps some chicken soup, a hamburger medium well, a salad with Italian dressing, some iced tea with lemon, and for dessert, half of a grapefruit. Well, to tell the truth, I like just about everything, don't I?
I know what I like.
What?
Ice cream, chocolate bars, and soda.
Well, then we need a very big space capsule to make room for the fattest little astronaut in the world. Right, ma'am?
That's right. Now, don't talk, just eat. Actually, cooking's a real pleasure in this house. John's a good eater. He likes salmon salad, chocolate pudding, spaghetti with meatballs, rib roast. Well, just about everything, right?
Right.
We have a lot of different choices, but you'd be surprised at how many of the astronauts, like you and me, like to eat the same kinds of things. So our task became easier. Food and nutrition experts, farmers, scientists, and doctors from all 50 states, plus many foreign countries as well, became involved. And our menu for an astronaut quickly developed both as a food venture into space and as a brand new concept of food programming for Earth people as well. Here at the Whirlpool Laboratory in Benton Harbor, Michigan, foods for the astronauts are processed and carefully packaged by experienced food production people in space food kitchens where purity and cleanliness reign supreme. In these clean rooms, as they are so aptly called, the selected foods are cooked and simmered, then fast frozen to retain their taste and nutrition, and finally freeze-dried to remove moisture. There are two basic types of freeze-dried foods on our bill of fare. Rehydratable, or food that must be reconstructed with water, like chicken salad and butterscotch pudding, and solid bite-sized cubed foods which are eaten directly from the package. Toasted bread, fruit cereal cubes, and cheese and crackers. Strawberries and cornflakes, there's a tasty dish. First, the sugar-coated cereal is mixed with freeze-dried strawberries and other wholesome ingredients. Then the mixture is pressed into cubes of a specific size and weight. Hand dipping in a special gelatin coating designed to hold crumbs to a minimum is the next step, after which the cubes are freeze-dried and placed in containers for interim storage. Each freeze-dried item has its own spacesuit of a 4-ply package manufactured by Whirlpool. The inside layer is food compatible. That is, it doesn't affect quality or taste. The second layer provides overall burst strength. The third acts as a vapor barrier, preventing the seepage of gas and liquids. And the fourth, or outside layer, is heat sealable. In addition, the total package is automatically vacuum sealed, which assures against bursting even in a complete vacuum. Quality control, you bet. All space food is checked and rechecked innumerable times daily. And to make certain that the appetite and taste appeal remains tops, the foods are tested by a time-proven method: eating.
Since astronauts do not have the time to either peel or squeeze a fresh orange, scientists in Winter Haven, Florida, developed a process that has transformed their daily vitamin C requirement into rehydratable crystals. And here in sunny Florida is where it happens. The concentrated orange juice containing 58% orange solids is brought from the refrigerated warehouse and dumped into a stainless steel hopper, where a rotating blade chops up the lumps of the concentrate that remain frozen. The liquid concentrate is then pumped at a measured rate through a continuous beater which whips it into a foam the consistency of marshmallow cream. All important measurements on the drying equipment are recorded and controlled automatically on Foxborough instruments. The switches for the various parts of equipment are centralized on the control panel. Nitrogen and a small amount of protein whipping agent are injected into the flow of concentrate and beaten to form a fine textured foam. This casting box spreads the foam onto a 4-foot wide stainless steel drying belt, which travels at 150 feet per minute. The foam is transferred into the casting box, after which it flows onto the traveling belt. The front of the casting box has an adjustable gate that controls the thickness of the film on the belt. The temperature of the foam, as well as other characteristics, are continuously monitored to produce a uniform product. Periodically, a sample of the foam is filled into a standard volumetric container and weighed on a balance to determine its density, keeping it within the optimum limits to produce a uniform product. The thickness of the film is measured periodically with a rotating paint gauge. This is a stainless steel cylinder with a cam section, which indicates the thickness of the film on the belt. The machine is 200 feet long, and telephone connection is provided to keep contact between the crews at each end. The harvesting end is located in a low humidity room to keep the dry product from picking up moisture. The dried sheet is stripped off the stainless steel belt with a stainless steel knife. The sheet itself, which is stripped off while it's still slightly warm, is of a plastic consistency. After passing through a chilling section, the sheet hardens, becomes crispy, and is readily broken up into flakes. The flakes are milled to yield powder of the proper size. The pneumatic conveying equipment ends in a stainless steel hopper used for filling the drums. A plastic bag is used in this shot to demonstrate the appearance of the product, which normally is filled directly into fiberboard drums. The drums are multi-walled and contain a sheet of aluminum and a sheet of polyethylene, as well as fiberboard to protect the product against moisture and oxygen. Several other types of containers are used in addition to the fiber drums. 1-pound vacuum-sealed cans containing desiccant bags are the common form used by the Quartermaster Corps. And here, ready to be consumed in the NASA drinking pouch used in the Apollo program, are the Florida orange crystals, a product about which the astronauts remarked had more of an adult taste than the very sweet citrus-flavored synthetic powders previously used.
Scientifically planned convenience food have almost become a way of life in our rush-around world. Spaceflight innovations have already given us a new type sandwich spread, many dehydrated soups and salads, a nutritious candy called, you guessed it, Space Sticks, delicious crystallized orange juice, a new form of rice, plus innumerable other tasty products.
Yes, people, whether they be on Earth, beneath the sea, or in outer space, enjoy well-prepared, tasty, nutritious foods, whether it be breakfast, lunch, dinner, or at snack times. And to satisfy and please them all is the name of the game. There's no end in sight. The length and breadth of our fantastic food adventure is growing and growing, and although it is key to space exploration, it is rapidly spreading its pleasures through innovative spin-off developments in our Earth-oriented foods, making them tastier, more nutritious, and above all, more convenient for us to prepare. You can be certain that future ventures to Venus, Jupiter, Saturn, or what have you, while providing a tastier choice from our menu for an astronaut, will also please our palates as well.
Cape Canaveral, Florida, man in space. In the nose capsule atop the giant booster is a man on the threshold of a new challenge, waiting for the blast-off that will send him in an orbital flight through space.
The blast-off is still planned for 7:15 a.m. Eastern Standard Time. We're going to have another report.
He is not alone. He is all of us in our relentless search for knowledge in the unknown of space. We wait and we watch.
Mercury capsule? Go. All pre-start power lights are correct. The ready light is on. Eject Mercury umbilical. Oil evacuate. Mercury umbilical is clear.
All reporters in the
Range operation. Cleared and launched.
Vernier
We're going to Mercury control. Control the foundation 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
The towers of Canaveral give Florida a unique place in the history of man. Moonport, USA, Moonport of the free world. From here, man of the Western world will depart on his greatest adventure, a trip to the moon. This cape on Florida's Atlantic coast is so well suited for its role in the space age, it is almost as though it had been destined through the centuries just for this moment in history. It juts out into the ocean like a gigantic launching pad, surrounded by water. It is isolated and secure, yet the spectacular firings can be watched from safe distances. Free and open to Floridians, their millions of visitors, and the whole world. Downrange it goes, passing over a string of islands 5,000 miles long, composing a geographic pattern ideal for tracking missiles. The Cape is a huge laboratory where boosters can be safely fired and their performances minutely followed for long distance. This laboratory, officially the Air Force Missile Test Center, is run by the Air Force in support of the Army, the Navy, and the National Aeronautics and Space Administration. The complicated birds are carefully checked and prepared for flight. Each of the intricate systems is checked out, all systems A-OK. Now the performance of each system is carefully recorded. Extraordinary cameras catch the action on film. Radar watches with electronic eyes. Telemetry, a method by which small sensors in the space vehicle send back weak signals to electronic ears, passes detailed information to the recorders. The data is processed for evaluation by scientists and technicians. All launchings, all firings are not successful. However, the collection of data during malfunction is even more valuable. Each launch yields knowledge. None is just a multi-million-dollar failure. Actually, what goes up, the boosters and missiles, are but a small portion of the expenditure. It takes people to make all systems go, and people mean salaries and buying power. Over 26,000 people are employed at the Cape, directly engaged in the missile and space programs. Thousands more are indirectly engaged. Families more than double the number. Still, many more thousands are needed to provide the services and goods that space workers and their families need. This means a rich and expanding consumer market. Brevard County, site of Cape Canaveral, is the fastest growing county in the United States, more than tripling in 10 years. But the Cape area is more than missiles and the space program. It is still a delightful place to live or to vacation. The space birds are just an added attraction. Fishing has always been excellent in the Indian River country, whether in the ocean or on the river. Whether the fisherman is a tourist or space scientist, the thrill is the same. All water sports are popular in the area. The Indian River, protected by the long barrier cape, is perfect for safe, sheltered boating. From one of man's oldest modes of transportation to his newest is but a step, here where the impact of space has marked almost everything. New buildings in every category, such as hospitals, schools, like Satellite High School, churches of many denominations have been built by growing congregations in the very shadow of space-age installations. There's the invigorating growing quality of a frontier, but a wholly new kind of frontier, sophisticated, scientific. Its people are young, vigorous, and well-educated. In fact, the greatest concentration of doctoral degrees in the country is found at the Cape. The caliber of personnel for companies like these creates an impact far greater than their number. The space scientists have been responsible for founding an engineering college close by the Cape. Universities throughout the state have stepped up programs to train young people for space and related work. Off-campus courses in technical subjects are made available to space industry scientists through the Institute for Continuing Studies, which has university status. Enrollment in technical colleges at the universities has increased as opportunities for technical employment in Florida have increased. The Engineering and Industrial Experiment Station at the University of Florida does research for Florida industries, including those in the space field. Among many space-related studies at the Florida State University's Institute of Space Bioscience is one on living cells sent into space and recovered for scientific observation. The impact of space extends far beyond the Cape area. It has been felt throughout Florida. Pratt Whitney, near West Palm Beach, is a major facility. Nearby is the free world's largest liquid hydrogen plant, built and operated by Air Products and Chemicals for the Air Force. Florida's largest industrial employer is Martin of Orlando, employing more than 10,000 skilled workers. Plants this size create their own impact by stimulating the establishment of feeder companies. Over 800 smaller Florida businesses supply Martin with everything from components of missiles to services for employees. Industries contributing to the space effort are located from Pensacola to Miami, turning out a variety of sophisticated electronic devices scarcely dreamed of a few short years ago, tracking devices to trace and record missile behavior, guidance system components for celestial navigation, recorders, computers, tubes, and thousands of other electronic parts. Small companies employing a handful, branch plants employing several thousand, all part of a growing space-age technology in the Sunshine State. Because of the nature of their products, these plants are attractive additions to the Florida scene, and their highly trained, skilled personnel are attractive additions to Florida's population. They earn good salaries, build substantial homes, and raise intelligent young Floridians. New Floridians have created a rapidly growing consumer market, graphically illustrated by the growth in retail food outlets. The number of Winn-Dixie stores in Florida more than doubled between the first launch at Cape Canaveral and the Mercury orbits. Similar growth has been experienced by Publix and other chains. These stores are usually basic to the development of sprawling shopping centers. There has been an extensive cultural impact because of the educational level among space-related personnel. New orchestras have been founded and older ones strengthened. Florida has more community theaters per capita than any other state. There has also been significant growth in public libraries, their facilities, and their use. Although Cape Canaveral and the Atlantic Missile Test Range make most of the headlines, it is not the only missile test range in Florida. The Air Proving Ground Center at Eglin Air Force Base in the Florida Panhandle operates the Eglin Gulf Test Range that includes tracking stations along the length of the Florida Gulf Coast. Tactical missile systems such as the Beaumark are tested at the operational level. At the western tip of the Florida Panhandle is the Annapolis of the Air Pensacola Naval Air Station and the Space-Related School of Aviation Medicine. Unusual equipment at the Disorientation Center causes the fledgling astronauts to experience the stresses, strains, and disturbed equilibria of space travel, known as vertigo. The school's work in space programs began long ago. Baker, the astro monkey that journeyed to the edge of space, was trained and still lives in the school's animal laboratory. Impressive as it is, the impact of space on Florida is actually just beginning. The expansions of Cape facilities to accommodate new programs will require 7 times as much land for the Missile Test Center. And on the land will be built facilities of such tremendous size and complexity as to stagger the imagination. Sections of the advanced Saturn will be brought to the Cape on huge barges and then assembled erect in a building over 500 feet high on special mobile gantries. Then doors as tall as a 45-story building will open and the assembled boosters will move to the launching sites. Advanced Saturn and other programs will require additional thousands of workers, first to build and then to operate the facilities. New industrial plants will rise to furnish the boosters, the components, the goods, and the services, swelling jobs related to space probes by many more thousands. All these people working toward that historic day, soon, before the end of this decade, when a giant booster generating millions of pounds of thrust will thunder from Florida's coast, carrying the banner of the United States and the hopes of free peoples everywhere to the moon and beyond.